Hello there, this is Brian Long. I'm a freelance consultant and trainer working with various development tools including Delphi, and this session is about accessing aspects of the Android system that aren't directly surfaced by the FM application framework or indeed the runtime library wrappers. There's quite a bit to cover in this 40-minute session, so I'm going to press straight on. First of all, it needs to be made clear, as I'm sure it's been made clear in various other sessions, that Delphi is generating native CPU code, as Delphi typically does. It's generating ARM CPU code, taking advantage of the additional Neon instruction set available in many ARM chips. And this kind of sets itself slightly apart from the normal Android SDK code, which is running in a Java virtual machine or a Dalvik virtual machine. We can still access the various APIs available from Android, but we do have to import them and access them via a mechanism called the Java bridge. It's fairly parallel to how you'd import Windows API functions in traditional Windows Delphi. It's just a case of writing the translating the Java interfaces into Pascal and consuming them. This is achieved using a technology called the JNI, or the Java Native Interface, which is a technology that was developed in the 90s to allow Java code to call into native code, but works equally well the other way, allowing native code to call into Java code, or in this case it allows Delphi code to call Android SDK API calls. The wrapping up of the JNI is done in a bunch of runtime library units. Let's just see if we can find some of these from the main Delphi subdirectory inside of source RTL Android. We can see a whole bundle of source files here relating to the implementation of Android. Many of them start with a prefix of Android API.jni, and these are all examples of SDK calls imported via the Java bridge. The Java bridge itself is implemented in a unit a little bit further down called, well, it's actually called JNI bridge, but it's referred to, generally speaking, as the Java bridge. So the JNI bridge unit is the starting point, and this is where the key elements of the Java bridge are implemented. If you wanted to have a look at the specifics, you can pull that in to Delphi. Let's just open that up. And in here we can see there's a bunch of interfaces, and the way the Java bridge is managed is via typically a couple of interfaces and a class. So ignoring all the plethora of stuff there, which typically is irrelevant, let's in fact actually look at a small example of one API that's been imported. The API that controls the little vibrating unit inside of most Android phones and tablets. So I'm going to go back to the Explorer and pull in Android API.jni.os and have a look at that. And in here I'm going to look at the vibrator. And the vibrator is managed or imported via this little section here. What we have is two interfaces. We have one interface which defines any class functionality that is accessed via the class and not an instance, and then another interface which defines all the members which are instance methods. So all of these functions here, cancel, vibrate, these are all interface methods. So the way that this is set up, in this case the vibrator has no class functions, but it does have a selection of instance functions. We have the interfaces defined. They both have IIDs defined, and the interfaces are inheriting from other interfaces representing the ancestry and inheritance lines of the classes that these interfaces represent. So if we went to a browser and looked up the vibrator class, we would find that vibrator is part of the Android.os namespace, and it inherits from java.lang.object, the basic object class in Java. So we can therefore see why the vibrator class interface inherits from the object class interface, and we can also see why the vibrator instance interface inherits from the object instance interface. Clearly you can see that a J prefix is used over the more typical I interface prefix, obviously because we're dealing with Java classes. All the declarations of the methods are straightforward translations, so if we looked at the methods for the vibrator, we'd see vibrate, which has a long and an integer, and cancel, which takes no parameters and just returns a void, which is the same as a procedure. So we can see here that cancel is a procedure, vibrate takes an int64, which is the same as a long, and we can see that vibrate here takes a pattern, which is an array of int64s and an integer. So we've got the two classes declared, vibrator class and vibrator, and then they're merged together, they're bound, they're bridged together via the tjvibrator class, which uses a generic class to merge the class interface and the instance interface, and there we have the representation of an entire Java class methods and instance methods alike. Now we'll come back later and see how we could go through these steps ourselves to import an API that is not already wrapped up by Delphi's import. And again, just like with the Windows API imports in Delphi, not every single API from Android is imported. A good number of them are, but not every single one of them. It's not an exhaustive representation. So there's always scope for pulling in additional APIs to serve your needs, as the case may be. I guess for completeness, I should probably also mention the attribute that's tacked onto the instance method interface, which simply allows the Java bridge to bind this particular interface, and indeed the other one that's bound up in the generic class, back to the underlying Android class to which it represents. In addition, other aspects that may come in useful are the fact that, yeah, these interfaces and generic class below can indeed represent a Java class, but it's sometimes useful to be able to get access to the actual Java object ID, the opaque pointer to the Java object, as opposed to the references to the Delphi object wrappers. And we can easily do this also because every one of these interfaces, or the interfaces that all of these class method and instance method interfaces inherit from, the base interface, i.e. local object, has a method called getObjectID, which returns you back the opaque reference to the Java object. So whenever you need to liaise directly with the Java object, that's perfectly manageable. Now, when working with the Android SDK, there are often times you need to access various common things, such as an activity or a context. And because these things are very common, and because it's not necessarily directly obvious how we get access to these SDK related notions from a Delphi Android application, there are a number of helpers provided in a couple of units around the framework. So let's go and have a look for an FMX unit. So in the FMX directory there is a unit called fmx.helpers.android. There's a corresponding one for iOS as well, but we're not worried about that in this session. Inside of this unit we can see a bunch of utility functions. So anytime you need access to an activity, where an activity in Android terms is essentially the object that represents a screen of UI, we have the shared activity function available. Also sometimes you have a specific need for a context. Context is actually an ancestor of the activity type, but just to be more convenient, shared activity context is available and gives you the context for the activity that is represented by your Delphi forms. We've also got access to private preferences, which is the way of doing simple local storage in the Android manner. We've got access to the package path, and sometimes it's important to invoke some Android functionality in the context of the Android UI thread. And with these helper methods here, call in UI thread and call in UI thread and wait finishing, we can package up a bit of functionality, maybe in an anonymous procedure or in an actual literal procedure, pass them into call in UI thread, and they will be executed on the thread that's being managed by the Android side of things as opposed to the Delphi side of things, to ensure that all the ducks are in a row. Another useful facility is found inside of fmx.types. fmx.types does offer us a couple of ways of doing logging functionality. Let me just get rid of some of these windows so we've got more. Whoops. Some. Try and press the right buttons. Let's just get rid of some of these windows so we've got more space available. Logging is a perennial debugging assistant. In order to get additional information from an application, having a way of emitting log messages is pretty much necessary. In the case of Android, we have a logging view mechanism as well, which we'll come to. However, the couple of ways that we could deal with logging, there are two of them that FireMonkey offers. One of them is the ifmx logging service, which we can request using supports platform service, and we can then get an interface reference out and we can call that interface references log method. But to be honest, that's a little bit convoluted and verbose. I tend to prefer to go straight for the class method of the log class. So there's a log class there, and there's a class method called d, log.d. So log.d has a whole bunch of overloads, which take either a message or a message and a bunch of parameters to insert in a formatted output manner, or an object that you want to dump. And anyway, there's a whole bunch of different overloads of log.d. It's a very convenient means of doing logging, and it's implemented on both iOS and on Android. So it's a cross-platform option which is more concise and easier to manage than using the IFMX logging service, which, whilst perfectly valid, is just a little more verbose. They can be seen in a couple of ways. The most common ways of viewing emitted log messages is via one of two UI tools supplied as part of the Android SDK package. So, when you install Delphi, if you allowed Delphi to install the SDK and the NDK, then you'll have the tools available, but the paths won't be set up. So you would need to find where the SDK is installed, which is in the user's public documents RAD Studio directory tree somewhere down there. My SDK was actually installed prior to installing Delphi, so my path to my SDK is actually just the Android SDK Windows directory, but you'll have a similar directory, possibly way under the public users documents RAD Studio directory tree. Ultimately though, it's useful to set up a path to the tools and the platform tools directories. In the tools directories, we have a batch file called monitor. There's also another batch file called DDMS. They both ultimately do much the same sort of thing for us with regards to logcat. DDMS, however, will tell you that it is deprecated and will advise you to use monitor. Monitor, when it runs, looks something like this. Monitor, when it starts up, doesn't necessarily have its layout like this. You may have to reorganize things, but basically you're looking for the DDMS, or the Dalvik Debug Monitoring Service section, and then you're looking for logcat. And when you get logcat, you can see all the various system applications and user applications emitting their log messages coming out listed here dynamically. Okay, let's get some code on the boil. Let's switch this back to its normal view and make a new project which will save away. And we'll put a button on here. Which will be designed to make the thing buzz. In fact, actually, let's add in all the relevant items. So it's Android API.jni.os. And we'll also make use of that helper unit. And a couple of other units which will come in handy. Okay, I think that's probably enough to be getting along with. So what we'll do down here is we'll declare, well, the first thing we ought to do is actually check the documentation on how the vibrator should be used. So let's pop back here and see what it says in the Android documentation. The Android documentation says to obtain an instance of the system vibrator, call getSystemService, which is a method of context. Okay, so that's we'll need to get our form's context to call that. So call getSystemService with the vibrator service flag as an argument. And vibrator service, that's a flag of, again, context. So we're going to need to get access to some generic object from getSystemService. So that's going to look like this. Right, we need to get access to it via the activity. Shared activity was one of those helper methods. So from there we can call get system service, and then from here we need to access a field. Vibrator service is a field of the activity class. So in order to access class members, we need to first of all reference the generic class, then use the property which gives us access to all the class members, and from there we can access whichever class member we need. So that gives us access to an object, a Java object representing that vibrator, but we need to typecast it back to a JVibrator, the relevant interface. JObject is too limited, doesn't have all the right methods. So in order to do that, well, we'll need another variable. And then we'll need to pull out the underlying object ID, so pull out the actual address of the Java object from the JObject representation and wrap it up in a JVibrator representation. So there's a wrap method inside of this class which allows us to take a pointer to a Java object and wrap it up in a, oh, it might help if I spelt it right, and wrap it up inside a Delphi wrapper that represents a JVibrator object. So in order to access the underlying object ID, you'll recall that I said that every interface in Delphi that represents a Java object happens to implement local object, and from there we can call get. We can call get object ID, assuming I've got all the relevant things in the uses clause, of course. I might have forgotten a rather key one. That one, the actual Java bridge itself. I think that might make things a little easier. Yeah. Okay, so having got the vibrator out, we can then say vibrator.vibrate and make it vibrate for maybe 1,000 milliseconds. Okay, so I'm going to run that, try and get it to focus on the thing. Okay, so we press the button and hopefully you'll be able to hear, hopefully you'll be able to see that there was a step missing. Okay, so whenever you get an exception like this, it's pretty obvious what the problem is. I forgot to add in the permission, and when you forget to add in a permission, it just turns into an exception. The application doesn't fall over. You don't have to look at logcat to find out where the problem is. You just look at the exception and deal with it. So let's pop back and add in the relevant permission. So into project options, uses permissions, and make sure we're covering all the Android platform configurations before going down and setting the vibrate permission. By default, there are quite a few permissions set which aren't really required, possibly just to cover your most likely development scenarios. So maybe we can turn off some of the ones we don't need. We don't need calendar. I don't think we need external storage, but I'll leave it on just in case. We shouldn't need phone state. We shouldn't need reading the calendar. We shouldn't need any internet accessibility in this app. We shouldn't need phone, camera, and shouldn't need GPS location. Okay, so let's try that again. Okay. Okay, so hopefully you can hear that buzz just about above the whir of my fan. Okay, good. And on to the next bit. Let's load up an existing project. Okay, one of the common things that is good to know about in Android is that many of the provided applications, either system applications or custom applications, provide activities for use by anyone who knows how to access them, and as a consequence it's convenient to be able to, say, launch a URL via the standard built-in browser activity, or have a look at the battery usage activity, or whatever. For example, create an email, create an SMS. So there is scope for understanding how to talk to these inbuilt activities, and this is done using the notion of intents, and an intent is an object-based message, and we package it up in the manner shown in some of these examples here. So for example, this launch URL routine, builds up an intent. It says let's initialize a new intent using the initialize class function of the intent interface. We'll initialize it with a view constant, and the thing that we want to view is the passed in URL turned from a Delphi string to a Java string and parsed into a URI using the URI class, which is imported inside of Android API.jni.net. So this will take a URL string, turn it into a URI, package it up into the intent, and pass it off to the system viewing intent. And the system will say, okay, I've got a URI, I need to view it, let's see what installed activities advertise the fact that they can handle this, and it will present you with a list of them, assuming there is more than one. So maybe you've got the built-in browser, maybe you've installed Firefox and Chrome on your mobile device. It'll give you a choice of these, and then the URI will be, or the URL, will be launched by that browser when the intent gets delivered to it. Same sort of thing with, for example, the battery usage. There is a standard constant for the power usage summary, which if you plumb that into an intent, you can first of all verify that that intent can be resolved to some activity, and assuming it can, you can then start the activity off. There's also one for showing tutorials. Android tutorials typically are on older devices, but creating an email or creating an SMS, that is more apt. And in fact, in the case of SMSs, you can actually create an SMS by talking directly to the SMS manager, and it's readily achievable to knock up a line or two of code, and it really is just a line or two of code which does that. The downside of creating your own SMS is that you have the requirement to add in the permission to say, I want to be able to create an SMS in my application, which then adds to the list of permissions that the user will have to OK when they install the application. If, however, you delegate the responsibility of creating the SMS to an already installed SMS creation activity, such as the system one, then that permission has already been granted to that activity, and your application need not apply that permission to itself. So in this case, what we have is a telephone number and a message being passed into a routine. We're building up a particular type of URL based around SMS2, so that's an Android SMS URL. That again is being plumbed into an intent with the action view constant, along with an extra piece of information. So we're using a put extra method of the intent, which takes the message, turns it into a Java string, and also plumbs it in via a sort of a key lookup field with SMS body. That's passed in, and then the activity is launched, and we get the SMS creation activity displayed for us. So let's have a look at some of these running. Let's just launch this. The application it's a list of things we can do. So let's see, where were we? So we've got the vibration option in there as well. We've got the options for keeping the screen on and checking whether we're connected to a network. All this sort of stuff's in this sample, which will be made available in conjunction with this session with the files from the conference. So, for example, view URL. Let's choose that, and we do get the choice list. It says I can find 2 activities which can service this view request for a regular URL. So if we just ask it to launch it via the standard internet browser, then up pops the URL in question. If we go back, maybe we can, what was one of the other ones? Oh, creating an SMS. So let's create an SMS. And again, so that's come up, and it's got the recipient, and it's got the message in there, so that's set that up. And same sort of thing for creating an email. Which one do you want to send this via? And so on and so on. Battery usage, much the same. Up pops the battery usage. So just some examples of taking advantage of pre-built functionality by understanding the notion of the intent message, the fact that we can package information in that to address activities that may or may not be installed on the system. And given an installed activity that can handle something, there could be many installed activities. So the system automatically offers a choice dialog. Some of the other things that may be of interest in this sample application could, for example, be the toast Now, toast is an Android-specific notion. It's a little pop-up message that will appear for either a small or a not quite so small duration of time. Toast is not wrapped up by the Delphi wrappers, so if we wanted to make use of the toast functionality, we can either try and find somebody who's already done it, or alternatively we can just step up to the mark and do it ourselves. So let's have a little look at how that will work. So the first thing that we need to do is we need to pop over to the documentation. So we go over to developer.android.com, we would look up toast, we would find that the full class name is Android Widget Toast, as shown there. And then if we browse down and find the standard way that toasts are designed to operate, the idea is you call a static method, so a class function, called makeText. You pass in a context or an activity, you pass in a string, or a resource ID to a string, and a duration. The duration flag is one of these two, so it's an integer constant defined inside the toast class. We'll see how we can surface those. We don't need to worry about what the definitions of the constants are. That could be implementation and platform API dependent. We'll use the constant fields. We'll ask the toast class what those field values are. Having called makeText, we'll have got a toast object back. We simply call the show method. All these other APIs, all these other methods, they're available for us if we want them, but typically all you do is you call makeText, then you call show. So bearing that in mind, the importing of it will look something like this. So what we have is a couple of uses. So we've got the basic Java bridge unit, JNI bridge, some basic Java types, which essentially are JObject and JObject class, and then another unit which defines a whole miscellanea, a plethora of various Android interfaces. So here is one of the two interfaces we define, here is the other. This is the class functions. This represents the instance functions. So in the case of the instance functions, there was just one. And again, this GUID is just a random GUID. You don't need to look it up or anything, you just make a new one. So Control-Shift-G pops in a new GUID. So that identifies this instance in this application, or this instance interface in this application. We have one method, it's called show. It takes no parameters, it returns nothing, but it must be declared using the C calling convention. In the class function interface, JToast class, we indicate that it inherits from JObject, just as we did down here for this JObject. We do implement makeText. We pass in, we have a parameter called context, which is of type JContext, the interface that corresponds to the Android context and class. We also pass in a parameter called text of type JCharSequence, and a duration flag, which is an integer. This is going to return back a JToast. It's again C calling convention. To surface any of the Java class flags, we declare them as properties like this. So length long, length short, put in the reader underscore get length long underscore get length short, and declare those as returning integers, which is what they're defined to return. That's all we need to worry about, other than binding the two together. So here we are declaring the merging class, the actual import class, TJToast. It's a class that inherits from tjava generic import and binds JToast class and JToast together. The only other detail really here is the fact that we are using the attribute to specify Android Widget Toast as the path to the class name in the Android class hierarchy. Other than that, I've added in a helper procedure called toast, which takes a message and an enum value, which is checked, and then we decide whether to use short or long as the toast length, and then we call makeText, which is a class method. So in order to access it, we access it via the toast class's Java class property, which gives us access to all the class methods, pass in the context for our Delphi activity, pass in the string turned into a JCharSequence, pass in the toast length, which was one of the two flags retrieved from the class, and then call the show method. Okay, I don't think there's anything else in there that I haven't covered, but what that then means is that if we go back to the form, there's my form. So if we go back to the form, where is the toast? There it is. So all we do is we pass in a message and a constant, and well, let's just switch back to my device, press the native toast, and that is an example of a toast. I have one final project I want to load up and show you. This project is going to show a number of Android techniques which have been asked about in various newsgroup posts and forum questions. I want to show that the things asked about can be done, and I want to go into a little bit of detail about how they're done. I can't go into excruciating detail simply because there's only about 8.5 minutes of this session left. But these are all quite useful Android techniques which, as updates come out for this product, should get easier, but in the interim period are actually achievable. So, first things first, a splash screen. It's been mentioned several times on the forums that Delphi's iOS support automatically adds in a splash screen, but Delphi's Android support does not. If we want an Android splash screen to appear as soon as the application is invoked, as opposed to when the full native library has been loaded into memory and kickstarted, then it needs to be written in Java. So over here I have a Java class, the details of which aren't entirely important, but it uses a thread and a runnable object in order to display an image that you deploy, and then goes ahead and uses an intent to launch your native Delphi activity. On the way through, it takes advantage of the fact that it's got a little bit of time to do some checking. It checks the OS version to make sure it's an appropriate level, and it checks the CPU is ARM7, and it also checks that we have Neon instructions. And assuming this is okay, then the application is allowed to continue. If, however, it finds an inappropriate piece of hardware or inappropriate operating system, it will alert the user with a toast message and then exit. Now, in order to use the splash screen, it needs to be compiled from source code into Java bytecode in a .class file, archived into a java.jar file, turned from Java bytecode into Dalvik executable code or DEX code using the DX tool, and then merged into the standard Delphi classes.dex file, which is deployed in every Delphi application such that it's available for launching as soon as the application is invoked. Now, all of those steps do require some functionality to be executed, and what I've also crafted is a little batch file which is operated via a bunch of variables and goes through invoking the compilation, the jar file creation, the DEX conversion, and the DEX merging. Now, again, the details you can check in the batch file at some later point, but just to make sure that we can see things in operation, the next step, once we've got a modified classes.dex file, is to go into the project deployment manager, and you'll notice that what I've done is I've taken the classes.dex, which comes from the Delphi distribution, and I've unchecked it, and then I've found my classes.dex file, which I built using my batch file, and I've incorporated that instead. So those are the steps required, with one additional one remaining. We need to tell Android about this new activity, which is going to be the start activity of our application, and that is done in the Android manifest, or more accurately in Delphi's case, the template for the Android manifest. So let's take a look at that. If we go and find the Android manifest template and open it up in the environment, the activity which normally resides inside of the manifest is this one down here, which has got the metadata that points to the native library. And what I've done is I've added another one. I've added another one which is a reference to my splash activity. I've also moved the intent filter from the original main activity into the splash activity, such that when Android is told to launch the application, it launches this splash screen activity instead of the Delphi activity. That's standard Android stuff. Again, the details aren't important, it's just a step that you need to take in order to choose which is your starting activity. One point to note about changing the starting activity is that if you try to launch the application such that it deploys onto your device and then loads up, well, if you've changed the starting activity, Delphi is not expecting that, and as a consequence, whilst it will deploy the application onto your device, it won't actually start it. You'll need to start it manually. That's something that's sat in Quality Central and hopefully will be attended to in some forthcoming update. Okay, let's see this in action. As mentioned, Delphi will install the application, but it won't launch it, so I'll launch it myself. And there we see the splash screen, which is formed from a FM application platform logo, and then the application starts up. And whilst I think about it, what we can also do is have a look in Logcat using the monitor application. We can see that the splash screen has emitted a couple of things to identify that it is a supported OS version. It's found a CPU that's appropriate and supports all the relevant instructions that are required before going ahead and launching. Okay, that's a splash screen ticked off. The other two items on the agenda, displaying a native Android menu and launching an activity from your activity and then getting some response back from the launched activity's execution, both have similar requirements. They both rely upon your activity overriding some virtual methods and executing some additional functionality. So let's have a look on the internet documentation for the activity type. First of all, for creating menus and working with menus, there is an onCreateOptions menu method which needs to be overridden, and then the menu gets created in there. There is also, when a menu item gets chosen, the onOptionsItemSelected method, which is triggered, and you're given a reference to the menu item that was selected, so you can then take appropriate action. That pair of methods is how menus are managed. And then the other one that's of interest is when an activity that you launched finishes and gives you a result back, the onActivityResult method triggers. Now, two of these methods that we're dealing with here, onActivityResult and onOptionsItemSelected, it would be good if we could get those to call back into Delphi and have Delphi code execute, such that we can write the logic that we want to write in our native Delphi language. So we are going to need to inherit from the activity that sits behind our Delphi application, which unfortunately is another Java class, so we'll be needing another Java class, and then we'll need somehow for that Java class to call some Delphi code, which means we're going to need to use some JNI to call from Java to Delphi, and then we're going to need to make sure that we switch over to the correct thread, because the Java UI operates on one thread and the FireMonkey framework code is running on a different thread, so we need to make sure that we switch over. So there's quite a lot of complexity there, which we can take care of, but it is feasible, and so the point here is simply to show you how to do it. So over here I've got an example of a class that inherits from the standard FMX native activity Java class. It does a couple of log calls, but primarily the important things is it overrides onActivityResult, it overrides onCreateOptions menu, and it overrides onOptionsItemSelect. And the two which I want to call out to Delphi code will call these native methods. So we've got these native methods declared, which will be mapped down into Delphi native equivalent methods. Back over in Delphi, if we were to have a look at the code, we would find that there is a section where the JNI setup is dealt with, and let's see if we can find the actual methods in question. So here is a native function. This is one that will be called from the Java code. It jumps through a couple of hoops in order to get the parameters, switch threads, and call into something that's a little bit more manageable. Really, all of this stuff is one-off setup code. So we tuck that in the background, and then we have a look at the actual methods that we want to be triggered, namely onOptionsItemSelected and onActivityResult, which I've entered here. These are called from those JNI routines. I've got a bit of logging, but if you ignore the logging, we're just checking that in the case of the activity result, when the barcode scan, which I've wrapped up in a helper method using an intent to launch the standard barcode scanning activity which people tend to install on their systems. When that comes back, we can check the information that the launched activity has returned to us, and then display some information, add something in a list box, whatever. This is all based around information that comes from the internet on how this activity works. Similarly though, the onOptionsItemSelected, when a given menu item is selected, we can check the resource ID of the menu is what we think it might be, and take an appropriate action, such as changing the style of the form. So, okay, let's just switch back to the application, and we should be able to see these in practice. So, firstly, let's check out the menu. Hold down my menu button. I've got a couple of menus which allow me to switch between dark and light themes. So if I switch over to the dark theme, that gives me the Android Hollow dark equivalent, and switching back to the light theme, right, as you can see, so just once more for good measure. So there we go, switching backwards and forwards through the styles using a couple of native Android menus, and then invoking the scanning functionality. So this will launch the installed barcode scanner, and then if I actually take the phone and scan a barcode, then the barcode scanner says, yeah, okay, it's going to return information back to the Java activity, which will then call down into the native method, which is hooked in and connected via JNI, which then switches thread and then calls into your regular Delphi method. So you do have that background monkey business going on, but ultimately we can call a standard Delphi method and display some information. We do get the ability to handle activity results, we get the ability to hook into standard Android menus, and we have the ability to have a splash splash screen which does appropriate hardware and appropriate OS checking. So generally, the things that we want to do in Android we can do, it's just how difficult a case is it? If you want to use Delphi for Android development, well, you've got the FireMonkey framework which gives you a certain amount of the UI building and a certain amount of the business logic building, but sometimes you want to reach out to the Android SDK and do some extra stuff that FireMonkey does not cater for you, and that's okay, you can do it. That's pretty much the time slot taken up. You have been watching Brian Long. Thank you very much for your attention. It's quite some interesting subject matter there. If you need help getting on top of this situation more, if you need extra pair of eyes or hands in your project, then do get in contact. But in the meantime, hopefully there'll be some questions that I can try and answer. Thank you very much.
What about creating background services on iOS and Android?
Yeah, background services. That one's come up quite a bit in the forums. It does require things to be registered in the manifest, and it does require, let's see, I think it's going to require some sort of Java wrapper, very much like the FireMonkey forms have a Java activity wrapper. I don't think anybody's done it yet. It is on my to-do list, but I haven't got to that point in the to-do list yet.
Oh, the race is on. Brian versus Jim McKeith.
Yeah,
or someone else.
Well, collaborate. Is it possible? Oh, this was already answered. Take a photo without firing up a separate activity, that passing it off to the share.
Yeah, I think he was using the action. That's the take photo from camera default action, which takes a photo and then you have to save it, which means it shows up in your camera roll. But I pointed to two areas. One is there's the T camera component, which will just have it and you can grab the image and keep it in your program. It doesn't have to go in the camera roll. And then there's the lower level sensor class T video capture device, which is available for your use as well, to get a video, to not use the component wrapper, but to do the lower level video capture, get the frame buffer, and do whatever you want with the image that comes in when the sample buffer is full. So there's a couple options there without using the share sheet and or the media action take photo from camera.
Okay, so a question here about broadcast receivers, which are an interesting feature of the Android platform.
I think it's going to be the same thing as with the activity and with on activity result. I think it's just going to be a little Java class which calls into some Delphi code. But again, the services, broadcast receivers, they're both on the to-do list. And whilst I got round to doing the on-activity result bit, and that works pretty sweet, the rest of it is still pending. So as I work out some of that stuff, I'll post it on the blog, or alternatively, I'll post it on my blog. Alternatively, if anybody else works out how to do it, then it'll be cool to see other blog posts elsewhere. But I think it's all going to be much the same sort of principle. If you want to invoke functionality, you can generate all the relevant import wrappers and you can call out to it. But for functionality which Android needs to call, it's going to be needing to find essentially objects living in the Java machine, in the Dalvik machine, and Delphi's code doesn't live there. So there's going to be a requirement, I'm pretty sure, for a Java wrapper, even if that Java wrapper simply does the JNI and thread switching and then calls into Delphi code.
Right. So the question about the source code of the barcode reading be available for download. So on your website,
already available. Yep. Already available on the blog post.
And just to be clear, what you were doing there is you were calling a separate app on the device that does the barcode reader and then returns your result back to your app, right?
Yeah, that's right. That it does warrant some extra clarification. Just like launching a URL where an activity that can handle a URL gets called, and there could be a choice of them that choose to respond to it. In that particular case, I was calling an activity specifically identified. It's what's it called, the zebra crossing barcode scanner, which is implemented in a commonly installed Android app. So yeah, I was referring specifically to that activity, which I guess also then helps answer the other question of how you could specifically invoke Chrome as opposed to just asking for a URL to be browsed, which came up elsewhere in the question list. But yeah, it was an externally installed application, but as is often the case with Android applications, that application surfaces its activity to any other application that wishes to invoke it, so long as it's invoked in the appropriate way.
How about using Google Maps API?
Yeah, I sent the link to the Google Maps on Google Developers page. One of the things you'll need now, it used to be, you can call Google Maps through a URL, and that's fine, passing a latitude and longitude. But if you want to use the API, now you need to get an API key.
Yeah, if you're going to
access the API, and that was a change from, I remember the first versions, but I don't think we haven't done anything to wrap. We just use the web browser component and pass it a URL to get to Google Maps. But there's the link to the API version 2. Seems like it should be easy to wrap, and then just go get an API key from Google.
So
yeah, I believe so.
Yep. And then it talks about someone asking if they use an ifdef, then they can use the XE4 barcode scanner and the barcode scanner you showed, and scan barcodes on both iOS and Android.
Yep.
Yeah, indeed. Ifdef iOS, ifdef Android, similar variations thereof.
And we've had those conversations here internally about how we can build. We had a whole conversation last week about components. Having, just as we have some multi-device components like for location and accelerometer and so on, to have more components that abstract across all the devices for things like barcode scanners and Bluetooth and so on. But meanwhile, you're not blocked. You've got Blong, so you're never blocked on iOS and Android.
Here's a question about the Java web view and keyboard pop-up integration, whether does work with the FireMonkey implementation or something where techniques of extending it would pay off. So I guess the idea is extending that to get access to more functionality, specifically around pop-up keyboard integration.
Yeah, I'm not entirely sure what it's asking, but of course the thing about the WebView component is that it is a component that abstracts from the WebView implementations on iOS and Android. So some of the specific support that the Android implementation offers, whatever that may well not be surfaced if it's not paralleled over on iOS. So perhaps some of the stuff that's being asked about there, something to do with the keyboard integration, maybe hasn't been surfaced, but I would imagine, yeah, you could take advantage of calling additional interfaces, whether they already be declared or whether they would need to be manually imported, possibly to extend the functionality of the WebView. Yeah, it's always a possibility to add in additional enhancements to these components.
Yeah, I seem to remember the T-Web browser component wrapper we have across iOS and Android will load web pages either zoomed or not zoomed, but that if you have fields where you need keyboard, you can't do input right now, or if there's JavaScript, there were some limitations that are being looked at. So going into the APIs to have full control of a web and view page and all the functionality that you'd want to use once you get there might be a good way to go for now.
Okay.
So here's a question. I'm not sure if this is going to apply here. It says, I've already have API keys for Android work and want to know where to place them in the Delphi FireMonkey version once obtained. I'm not sure if he's referring specifically to maps, because I mentioned that you need a API key for maps or something else, but any thoughts on that, Brian?
I'm just trying to cast my mind back to when I was doing some raw Android SDK work with the Google Maps API, and I did use an API key, and you plug it into a property of their view, don't you? So I guess if you end up wrapping up their map view or whatever it's called, then the API key would need to be assigned to the relevant property. Well, they don't have properties in Java, but passed into the relevant setter procedure, I guess. Yeah, somebody else just posted up that normally they go in the manifest, but I think they normally go in the manifest in the context. Oh, No, I'm just getting confused there between manifest and layout. Okay, so the suggestion there is from the audience is that the API key goes in the manifest. So my memory is a little hazy there. It's been a couple of years.
So they can edit their manifest template to probably be the best way to do that.
Apparently so, yeah. Yeah, I mean, it's, in essence, with a lot of the questions that did come up through the session of can I do this, well, with Delphi, the answer is, well, first of all, how does it work in Android in the first place? Once you have the answer to that, it's then fairly easy to work out whether it's a straightforward communication with an API to do it with Delphi, whether or not you have to import the API in the first place, or whether there's more work involved. But if you've got some steps already online, which there are numerous instances of how to work with the Google Maps API, then kind of follow the steps and work out which bits are readily paralleled and which bits need to be morphed for the Delphi way. But if something needs to be plugged into the manifest, we have the manifest file, so I guess you can just plug it straight in.
Yep. I think with all the pieces you showed in this session, exactly you said, just a matter of finding out what is the, what is it on Android you want to do, how is that accessed on Android, and then, determine if it's already imported, and if not, then follow the steps you covered to get there. So, yeah, you've unlocked the entire Android platform.
I posted the link. Somebody asked about Core MIDI framework for iOS, and I posted the link to the Apple documentation for look for Core MIDI as the framework for you MIDI folks.
So Michael's asking about this key again for maps. And it says normally go in the manifest. So yeah, if you look in the folder your app is in, there's a Android manifest template file. It's an XML file. And you can edit that file, and that file is what's used to generate your manifest that goes with your app when it's installed. So edit that file, and then that file is used to generate the actual manifest that's used when you build the APK. Okay, well, thank you very much, Brian. Another great session. A couple requests here to when we do the playback link, maybe to slow it down a little bit. I understand you got a lot to cover. You have to go fast, but I think you did a good job.
Yeah, it seemed to go okay. I managed to squeeze in all the things that I wanted to squeeze in, so it's good. I'm glad it was enjoyable.
It says here, I was looking at the Google Maps API key. Once you have the key, you add it to your application by adding an element to your application's manifest file, Android manifest.xml. That's in the getting started document. Let's see. I'll post it there and over in the chat window. Just look at the getting the Google Maps Android API, getting started the Google Maps API. It says here that the keys are free, but you need to tell them the app that you have that's going to be calling, so that they see the app and your key, and they'll let the API calls get passed through.
Yep. And then if you just in your Android project, just look in the project folder with all your source code where the DPR is, and you'll find an Android manifest.template.xml file. And if you look in that file, you notice it looks mostly like an Android manifest file. There's a couple of bracketed % uses permission type entries in there, and you just have to edit around those to change it to be however you want to have your anything you need to add to that manifest. So leave the percentage things that were surrounded by percents alone, and that's what Delphi will put in, and then you can add other stuff in there as you need to. And I believe you showed an example of that in your video as well. So,
indeed.
Excellent. Well, thank you, Brian. We'll have the links to your blog is there up on the screen for everybody, and they can download your source code that you just posted a few minutes ago, and everybody will be making amazing iOS and Android app with Delphi XD5.
Cool. Just a final note with the Android demos, so a number of them do require extra steps to be done at the command line, simply because they're kind of tricky. Detailed README files are in with each of those Android projects. Do follow the steps.